Q1. Briefly explain what you understand by correlation. Correlation is a statistical method used to measure the relationship between two variables. It shows whether the variables move together or in opposite directions and how strong their relationship is. For example, if students who study more get higher marks, there is a positive correlation between study time and marks. The value of correlation ranges from -1 to +1. -+1 equals perfect positive relationship, -1 equals perfect negative relationship, 0 equals no relationship. Q2. Write down where and why to use correlation. Correlation is used in research to study the relationship between two variables. Where and why it is used. 1. Prediction. It helps predict one variable from another. Example, previous exam marks can help predict future academic success. 2. Validity. Correlation is used to check whether a new test measures what it claims to measure. 3. Reliability. It helps determine whether a test gives consistent results when repeated. 4. Theory testing. Researchers use correlation to test theories about relationships between variables. Q3. Write down the considerations that should be kept in mind while interpreting correlation. While interpreting correlation, the following points should be considered. 1. Correlation does not mean cause and effect. It only shows a relationship, not that one variable causes the other. 2. Range of scores can affect correlation. If the data range is limited, the correlation value may change. 3. Outliers can affect results. Extreme values can greatly increase or decrease the correlation. 4. Correlation is not a percentage of prediction. For example, R equals 0.5 does not mean 50% accuracy. Instead, we square it, RFED, to determine prediction accuracy. Q4. Which formula is used to calculate Pearson correlation? The Pearson correlation coefficient R is calculated using the formula R equals frac SP SSX times SSY, where SP equals sum of product of deviations, SSX sum of squares of X, SSY equals sum of squares of Y. Pearson correlation measures the strength and direction of a linear relationship between two variables. Q5. Which formula is used to calculate Spearman correlation? The Spearman rank correlation, RS, is calculated by the formula RS equals 1 minus frac 6 sum d squared n2 minus 1, where d equals difference between ranks of X and Y, n equals number of observations. Spearman correlation is used when data is in ranks or ordinal scale. To have Q6. What do you understand by regression? Regression is a statistical method used to predict the value of one variable, dependent variable, based on another variable, independent variable. It finds the best fitting line, called the regression line, that shows how changes in one variable affect another. Example, predicting students' marks based on their study hours. Tash Q7. Why do we use regression analysis? Regression analysis is used for several purposes. 1. To study the relationship between dependent and independent variables. 2. To predict or forecast values of one variable using another variable. 3. To measure the effect of independent variables on a dependent variable. 4. To build models that explain real-world situations. Q8. Write down the types of regression. Common types of regression include 1. Linear regression, shows a straight-line relationship between variables. 2. Logistic regression, used when the dependent variable is binary, e.g. yes, no. 3. Polynomial regression, used when the relationship is curved or nonlinear. 4. Stepwise regression, variables are added or removed step by step in the model. 5. Ridge regression, used when independent variables are highly correlated. 6. Lasso regression, used for variable selection and improving prediction accuracy. 7. Elastic net regression, combination of ridge and lasso regression. Q9. Write a brief note on p-value. The p-value is used in statistical hypothesis testing to determine whether the null hypothesis should be rejected or not. It represents the probability that the observed results happened by chance. Key points. Small p-value, 0.05. Strong evidence against the null hypothesis, reject it. Large p-value, 0.05. Weak evidence, do not reject the null hypothesis. Examples, p equals 0.05. 5% chance that results occurred randomly, p equals 0.01, 1% chance, p equals 0.001, very strong evidence against the null hypothesis. Thus, the smaller the p-value, the